What's up, people, and welcome to the sixth part of my Introduction to Distributed Systems tutorial. So in this part we're going to talk about something called majority quorums. And if you have the book available, I suggest you head over to page 65 and read up on quorums, what it is, and why we have it and why it works. So basically, if you have a distributed system, like we do here, we have distributed data over 4 nodes. How many nodes do you have to write to before you respond so that you know that you have guarantees that all of them will receive it? Basically, how would you achieve strong consistency, if you remember from the CAP theorem? And in our particular case, it means that if we do a write here, we post a query that we wanted to save it, and then in our case, we want strong consistency, and that means that we would like to have some guarantees that when I do read later, I will guaranteedly get the most recently written value. And the solution to this is called majority quorum. Basically, I want you to remember this, like the number of read plus the number of writes must be strictly greater than n. So keep that in mind for now. And what this means is basically that in this case, n is how many nodes we have in the system. So here you can see an example where you have n equals to 5. So we have 5 nodes here, 1, 2, 3, 4, 5, right? And when we do our write, let's say that we decide that we're gonna write to 3 of these nodes. So w here is equal to 3. That means that when we later do a read, we must have this thing that we stated, basically saying that it must be strictly greater than n, which is 5 in this case. This means in practice that we will have to set the r to also equal 3. And as you can see, we will have when we have this, it will guarantees us that we will have overlapping quorums, because if you check this out, this situation we have written to 3 nodes. If we read from 3 nodes, there is no way we can not make an overlapping quorum in any way, And that means that when we later do a read from 3 nodes, at least one of these nodes that we're doing a read from must have the most written value, in this case the node here in the middle. So that is the basic theory, and you can experiment with this like back and forth with different numbers as long as it's strictly greater than 5, And this kind of depends also on your system. If you're doing like in the implementation that we're going to use, we're going to have W and R set to the same thing. Basically, we don't differentiate between a read and a write. But in some cases, you might have an application where it's very infrequent that you do writes, but it's very frequent that you do reads, which is the case in most applications. So what you can do in this case is you can have a bigger quorum for writes. So basically, in this case, you can say that, I'm going to have my W set to 4 and then my R set to 2. Then you don't have to read from so many nodes. And this will give you greater speed, of course, at the cost of expensive writes. So you can model this any way you like, but for sake of simplicity in the application, I have the same value for W and same value for R. And that also means that when you do this write, you cannot simply do a read from like 3 nodes in this case and then just pick any value whatsoever. But you need to have the Lamport clock that we talked about previously, so you know that if some message causally preceded some other, that you do the read from the node that has the last value written, in this case this guy in the middle here, because these guys, they haven't received the writes yet potentially. So you need to make sure that when you do the read, you do it from the one that has the highest timestamp. And since you have overlapping quorums, it is guaranteed that at least one of the nodes have the last written value if W is equal to 3, right? So they're dependent on each other. I hope this wasn't too confusing to you guys, but it should be pretty straightforward. There is a lot of material on this online as well, so I suggest you Google it and try some alternate sources if you didn't understand this. So I hope you guys enjoyed it, and I will see you in the next video.